Hello guys, in this video, I want to explain one of the most important concepts in electricity, and that is the Kirchhoff's law. If you understand the Kirchhoff's law, you can solve almost any complex circuit easily. Let's jump straight into it. We have the Kirchhoff's current law and also the Kirchhoff's voltage law. Let's start with the Kirchhoff's current law. The Kirchhoff's current law states that the total current entering a junction is equal to the total current leaving the junction. This means that in any junction, there is no accumulation of current. Now, the summation of the current entering the junction is equal to the summation of the current leaving the junction. Let's picture a junction. Let's say this is a junction, and we have different currents entering this junction. Let's say these are currents entering the junction, and these are also currents leaving the junction. So let's label our current I1, I2, I3, I4, and I5. So what Kirchhoff is saying is that the total current entering this junction, which is I1 plus I2 plus I3, is equal to the total current leaving the junction, which is I4 plus I5. But we can say that the summation of the current in a junction is equal to 0. That is I1 plus I2 plus I3 minus I4 minus I5 is equal to 0. So this is the Kirchhoff's current law. So let's look at the Kirchhoff's voltage law. The Kirchhoff's voltage law states that the sum of the electromotive force, that is the EMF, in any closed loop of a circuit equals to the sum of the potential drops across resistors in that loop. So based on this, based on the conservation of energy, we have that the EMF is equal to the summation of the potential drop. Let's picture a simple one-loop circuit. Let's say you have a one-loop circuit. You have a cell connected to a resistor, connected to another resistor, and you have a current flowing through this circuit. Let's say this is 12 volts. This is, let's say, 2 ohm. And let's say this is 3 ohm. Let's call this current I. So if you're applying the Kirchhoff's voltage rule, it says that the total sum of the potential drop in the circuit is equal to the EMF. Now, the EMF here is 12 volts. So 12 volts. And if the current is moving through this circuit following this loop direction, you see this loop direction is pointing, that is something like a circle, is going in a circular form. So this is going to be 12. Then the next component is the resistor, which is the 2 ohm resistor, minus 2I. Then you go on to the next component, which is the 3 ohm resistor, minus 3 ohm, minus 3I, is equal to 0. So we can conclude that 12 minus 5I is equal to 0. So this is the Kirchhoff's voltage rule. So let's look at a simple problem. You can see this circuit. It says, use Kirchhoff's law to find the current in the circuit below. So for us to find the current in this circuit, first of all, once you see questions like this, you put a direction to the loop. This is loop 1, and this is loop 2. Secondly, look at the current. We're applying the current first law first, which says that the total current entering the junction is equal to the total current leaving the junction. We picture this junction at this point. I1 is coming to meet this junction. I2 is leaving that junction, and I3 is also leaving that junction. So by Kirchhoff's current law, it says that the sum of the current entering, which is I1, is equal to the sum of the current leaving. I2 is leaving, and I3 is also leaving. We can call this equation 1. Now we go on to apply Kirchhoff's voltage law to each of the loops. Here we have 2 loops in the circuit. So we start from the first loop. In the first loop, let's start from the 30-volt battery or cell. So starting from there, we're saying that the current is going in this direction. It means that the current is going to pass through, come down, go back, and go back to the 30-volt battery. And you can see that the loop direction is also in the same direction as the current. which means that let's start from 30. The longer side of the battery is the positive, while the shorter side is the negative. So you're starting, it means that the current is going from the negative to the positive. So that is going to be 30. Then the next component in that loop is the 2 ohm resistor. And the current of I1 is passing through the 2 ohm resistor. So this is going to be minus because the loop direction is the same direction with the current. So there's going to be a potential drop, which is negative 2I1. We go on to the next component, which is the 5 ohm resistor. 5 ohm resistor, which is this. The loop direction is also in the same direction with the current, and that is going to be negative 5 I2. And that is all under that loop. So this is going to be equal to 0. Or we can say that 30 is equal to 2I1 plus 5I2. All right, we'll call this equation 2. We go on to the second loop. In the second loop, well, let's start from the 5 ohm resistor. A current of I2 is flowing through the 5 ohm resistor. So this is going to be, you can see the current I2 is going downwards while the loop is kind of facing upwards. Like the current is going to be moving, the loop is going to be in this kind of direction. So if you're applying that, it means that the loop and the currents are in opposite direction. So there's going to be a potential lift across the 5 ohm resistor. So that will be 5 I2. Then we'll go on to the next component, which is the 10-volt battery. So this is the negative and this is the positive. If the current is moving through, this current I3 comes and passes through the 10 ohm. So that is going to be passing through the positive side. So this is going to be positive 10 volts. Then we'll go on to the 3 ohm resistor. In the 3 ohm resistor, the current I3 is also flowing through the 3 ohm resistor. And if you look at the loop and the current, they are in the same direction. So this is going to be negative 3I3. And this is equal to 0. So from this equation, we can make this easier because what you're trying to do, we are trying to make this equation have both I1 and I2. Because if you're having I2 and I3 in this equation, and we're having I1 and I2 in the first equation, that is equation 2, we won't be able to solve these two equations simultaneously. So let's try to make these equations have 2 unknown instead of 3 unknown. So remember from equation 1, we said that I1 is equal to I2 plus I3. So we can just make I3 the subject of the equation. I3 is equal to I1 minus I2. So we can put this value into this equation. So if we put that, we're going to have 5I2 plus 10 minus 3 into I1 minus I2 is equal to 0. And when we expand that bracket, we're going to have 5I2 plus 10 minus 3I1 plus 3I2 is equal to 0. And when we add up, we're going to have that 5I2, 8I2 plus 10 minus 3I1 is equal to 0. Or we can say 10 is equal to 3I1 minus 8I2. We can call this equation 3. So yeah, when we get to this point, we solve these two equations simultaneously. That is equation 2 and equation 3. We can solve these two equations simultaneously. That is, you can solve using the substitution method, you can solve using the elimination method, or any method you prefer at all, you can solve, and you're going to arrive at an answer. I1 is equal to 9.35 amps, and I2 is equal to 2.26 amps. Now we're going to solve for I3. Remember, we said that I1 is equal to I2 plus I3. So we just use that equation. I1 equal to I2 plus I3. Now we know the value for I1 and I2, so we simply make I3 the subject, which is equal to I1 minus I2. We just put that into our equation. I3 is equal to 9.35 minus 2.26. That gives us 7.09 amps. So we successfully calculated the value for I1, I2, and I3, which are the values required for this question. So I hope you find this video helpful. Please like my video, and you can also leave a comment. And you can also do me well by subscribing to my channel to get more from me. Have a nice day.